To make sure we have a good comfort level with applying the empirical rule, we'll consider another example. Here we entertain questions about the heights of adult women. It is known that the heights of adult women are normally distributed and that the mean is 63.5 and the standard deviation is 2.5 inches. Before we even look at any specific questions, we step back and apply the percentages given in the empirical rule to this data. My preference is to do this graphically, so on the next slide you will see 3 graphs, one to answer the 68% question, another for the 95% question, and a third for the 99.7% question. So here are 3 bell-shaped curves. 63.5 is located at the center because it is the mean height. We are told the standard deviation is 2.5, so we successively add 2.5 to get 4 markers above the mean. Adding 2.5 once, we get 66. Again, we get 68.5. Again, we get 71. And a 4th time, we get 73.5. We stop at 4 since it's extremely rare for an observation to be 4 standard deviations above the mean. In a similar fashion, we subtract 2.5 to get the numbers to the left of 63.5. Subtracting once is 61, twice is 58.5, 3 times is 56, and subtracting 2.5 a 4th time is 53.5. Now we know that 68% of the cases or women are within 1 standard deviation of the mean, so 68% of adult women have a height that is between 61 and 66 inches. Similarly, we know that 95% are within 2 standard deviations of the mean, so 95% of adult women are between 58.5 and 68.5 inches. And finally, 99.7 are within 3 standard deviations of the mean, so 99.7% of all women are between 56 inches and 71 inches tall. So let's look at a few questions. First question, what percent of adult women would you expect to have a height of 68.5 inches or less? Of the 3 graphs that appeared on the previous slide, it is the middle graph we need here. That is because 68.5 is exactly 2 standard deviations from the mean. The analysis goes like this. Between 58.5 and 68.5 is 95% of the cases, or 95% of the women. The rest, namely 5%, are in the upper tail or the lower tail, and since the distribution is symmetrical, half of those women, half of the 5%, or 2.5%, are taller than 68.5 inches, and half are shorter than 58.5 inches. So next we draw a graph to represent the question. The question is, what percent are shorter than 68.5 inches? So we shade below 68.5. And we see that this includes all of the women in the middle together with all of the women in this lower tail. Hence, the percent of women that are 68.5 inches or less are the 95% in the middle, together with the 2.5% in the lower tail, or a total of 97.5%. Some people find it easier to think of the shaded area as simply excluding the top 2.5%. It's all of the women, 100%, minus the 2.5 in the upper tail, which of course again gives us 97.5% are shorter than 68.5 inches. What about the percent that are shorter than 61 inches? Since 61 is exactly one standard deviation from the mean, we will use the first graph that captured the middle 68%, leaving 32% to be split equally between the two tails. 16% of the women taller than 66 inches, 16% shorter than 61 inches. And that is precisely the question that is asked. If we draw the graph to represent the problem's question, 61 inches or less, we see that that is 16%. Finally, our final question is, and this is the most challenging because it mentions two numbers, one that is one standard deviation from the mean and the other that is two standard deviations from the mean. Here's the question. What percent of women are between 61 and 68.5 inches tall? Between 61 and 68.5 inches tall. Now 61 is exactly one standard deviation from the mean, and 68.5 is two standard deviations from the mean. And the graph at the bottom of the screen shows the shaded area that is referred to in the problem. All women between 61 and 68.5. Perhaps the easiest way to handle this is to ask ourselves which women are left out. They would be the women that are shorter than 61 or taller than 68.5. We know both of these percentages. Shorter than 61 is 16%, and taller than 68.5 is 2.5%. So from 100% representing all women, we subtract the 16% that's below 61 and the 2.5 that's above 68.5 and realize the rest, namely 81.5% of women are between 61 and 68.5 inches tall. Can you see how this graph summarizes everything? 68% within one standard deviation. The remaining 32% split evenly between the tails, 16% and 16%. 95% is within two standard deviations. This leaves 5% to be split equally between the upper two tails. So if we subtract the 2.5% from the 16%, we get 13.5% for the piece between 66 and 68.5. Similarly, 13% for the percent of women between 58.5 and 61 inches. Please refer back to this slide often. It gives all the percents you need to solve almost any problem involving the empirical rule. Here's another example. Suppose the weight of a Milky Way candy bar is normally distributed with a mean of 2 ounces and a standard deviation of 0.04 ounces. What does the empirical rule tell us about the weights of individual Milky Way candy bars? We set up our bell-shaped curve to have a mean of 2 ounces. We mark off increments of 0.04, since 0.04 is the standard deviation on either side, to get, starting at 2, 2.04, 2.08, 2.12, and 2.16. And on the left, 1.96, 1.92, 1.88, and 1.84. So the one standard deviation interval extends from 1.96 to 2.04, and that contains 68% of the candy bars. Similarly, 95% weigh between 1.92 and 2.08 ounces, and almost all, or 99.7%, of Milky Way candy bars weigh between 1.88 and 2.12 ounces. Once again, this picture tells it all. There's 68% between 1.96 and 2.04 ounces, 16% more than 2.04, 16% less than 1.96 ounces, 95% between 1.92 and 2.08 ounces, and so forth. Here's one for you. Read the question, then pause the video and draw your own very detailed graph. Human pregnancies are normally distributed with a mean of 260 days and a standard deviation of 15 days. Now pause the video and sketch a graph that uses the percents mentioned in the empirical rule. Hopefully this is what you got. Take a moment to examine the graph carefully by pausing the video. And here is still an even more detailed graph. Pause the video and make sure that you understand it well.